All right, in this video, we're going to simplify complex fractions. All right, before we jump into it though, I want to remind you of what you learned long ago in a little flashback. All right, so let's flash back to middle school when you first were introduced to fractions. Maybe you remember this, maybe you don't. If you had a fraction divided by a fraction, do you remember what you did? You had to multiply by the reciprocal. That means I flip this one over and I multiply. And then I look at what I have. Well, if I have a 5 on the top and 5 on the bottom, they will cancel out. And then I follow the basic multiplication rules, top to top, bottom to bottom. And I'll end up with 3 over 4. And that's my answer. So if you remember, when we divide a fraction, we multiply by the reciprocal. All right? That was the old rule, and it's the same rule we're going to use today. We're just going to get a little more complicated in our fractions. So the instructions will say simplify. Now, in today's lesson, we're going to simplify, and you're not going to list restrictions. So don't list restrictions. We got enough going on these questions. So let's look at this first one. 3 over x divided by 8 over y. All right, the rule says I'm going to flip this over and multiply. All right, this is now gone, and I multiply straight across. So I'll have 3y over 8x. And I always look to see if I can reduce, but I can't reduce in this situation, so we're good. Let's try another one. 1 over x plus 10 divided by 5 over x squared minus 100. All right, this is a little more complicated, but the same rule applies. We're going to multiply by the reciprocal. Now, notice this is a difference of squares. So as I flip this over, I'm going to do a little mental factoring. Since I know it's a difference of squares, I know it's x plus 10 times x minus 10, all of it over 5 when I flip it, right? Then I think about this, okay, I have x plus 10 and x plus 10, so they will reduce, and my answer will then be just x minus 10 over 5. And that's my answer. I can't reduce this 10 and the 5 because remember the 10 is glued to the x by the minus sign. Only way you can reduce is if you could take a GCF out of the top and the bottom. Doesn't work on this one, so we're done. All right, now let's keep going. The key to this lesson is to multiply every term, by the least common denominator, all right? So this is what you want to make sure you do on all of these. So let's look at this first one here, number 1. I'm going to space this out intentionally. So 1 over x plus 3 divided by 5 over x plus 4. All right, so let's think about this. What is the least common denominator going to be here? Well, this is over x, this is over 1, this is x. So my least common denominator is an x. So now that I know my least common denominator, I'm going to multiply every single term by that x. So this one's a fraction, so I'm going to write it as a fraction. The next, that 3 is not a fraction, so I don't have to write it as a fraction. This one's a fraction, and then this is x. Now let's look what happens. The whole goal is to get rid of some of these fractions, right? So look, x divided by x cancels out, and I'm left with a 1 plus, over here, it's 3x over. On the bottom, those x's will cancel, and I have 5 plus, and then 4x. All right, now we want to put these in exponent order. That's still the rule of thumb, so we just kind of flip things around a little bit. So it's 3x plus 1 over 4x plus 5. All right, so there's one question for you. Let's try another one. 3 over y divided by 1 minus 1 over 2y. Okay, so what is our least common denominator going to be here? All right, well, we need at least a y, but look at this. The 1 has a denominator of 1, and this one has a denominator of 2y. So we know it has to be a 2y. So I'm going to multiply every term by 2y over 1, or just 2y. Then I think about how did we reduce. Well, the y's cancel out here. That leaves me with a 6 in the numerator. The denominator is 2y. Down here, those 2y's cancel out, and it's a minus 1. So 6 over 2y minus 1, and that's where we leave it. Again, don't worry about restrictions today. We're just simplifying these complex fractions. Let's try a third. This one is 2 over x plus 4 over y divided by 3 over y minus 1 over x. Okay, let's think. What is our least common denominator? What does it have to be? Well, we know it has to have an x. We know it has to have a y. And that should be enough, right? That should be enough. So let's multiply through by the xy. All right, now let's see what cancels out. My x's cancel out here. That leaves me with 2y. The second term, the y's cancel out, plus 4x. On the bottom, those y's cancel out, so I have a 3x, and then minus, those x's go away, minus y. Look at that, it's simplified out. Now, we need to clean it up just a smidge. We want to make sure we put things in alphabetical order. If you didn't know that's a rule, that's a rule. So we would do 4x plus 2y over 3x minus y. Now, can I factor? Yes, I can take a GCF out of that top. That leaves me with 2x plus y over 3x minus y. Now, I know I can't reduce anything with that, but we want to leave things in factored form. So let's make ourselves a note here. Answer is always factored, if possible, okay? Always factored if possible. Let's try another one. 3 over x minus 4 divided by 7 minus 2 over x minus 4. Okay, well, what's my LCD going to be? Well, x minus 4 looks like it has to be there. That's for this one. This is just a 1. This needs that. Already has the x minus 4. Now, remember the rule. You got to multiply through by every term by that LCD. Okay, see what happens. These x minus 4s will cancel out, and I am left with just a 3 on the top. Look how much it's simplified. On the bottom, now I want to be careful. I'm distributing the 7 to both terms, okay? So it'll be 7x minus 28. Here, I am noticing that the x minus 4's cancel out, so it's just minus 2. Isn't that nice? So when I simplify, I will have 3 over 7x minus 30. And it doesn't factor, so I just need to leave it just like that. And then we can move on to our last example, number 5. It's a little more complex, but you can handle this. So it'll be, I'm sorry. All right, the last one, 2 over x plus 7 divided by 3 plus 1 over x. All right, LCD, what do I need? Well, it looks like I have an x on the bottom. Definitely need an x. And I have this x plus 7 on the top. So it's a little more complicated in my LCD, but we can do this. So I'm going to multiply every term. Remember, every term needs this LCD, so we're going to multiply it like that. This is going to be x times x plus 7. And this is x times x plus 7 here. Now let's see what cleans up. X plus 7's cancel out, and I'm going to be left with a 2x on top. Over here, now this 3 needs to get distributed across with that x, right? So just cross that out, move it to the front. So that would make it 3x squared plus 21x. And in this term, the x's fall out, so I'm going to have plus x plus 7. Okay, so let's clean that up a little bit. We can combine these middle terms. So 2x over 3x squared plus 22x plus 7. All right, so we're going to need to do a little factoring here. So I'm just going to set this over to the side for a second. We're going to factor. Now, we can't use our shortcut because of that lead coefficient. Now, that means we got to look two numbers that multiply to what? 21, but add to 22. Okay, that would be just a 21 and a 1. So if we break it up, we have 3x squared plus 21x plus 1x plus 7. And then we'll do GCF. So we have 3x. That gives me x plus 7. Bring down the plus sign. And back here, all they have in common is a 1, so it's x plus 7. So the bottom, the denominator on this guy, is going to be 2 over x plus 7 times 3x plus 1. Remember, we want to leave everything factored, okay? So we bring it back here. All right, once everything's factored and I've checked to see if there's a GCF or canceling I could do, I'm done. All right, I hope this all makes sense, and let me know what questions you have when you get to class. Good luck.